We're looking at the number e in this video. So e is a very beautiful number. It's really important in maths, similar to pi. So the number pi, for example, is irrational. It goes on forever and it doesn't really repeat. So the calculator looks like it cuts off, but there's infinitely many digits after that with no pattern or repetition or anything. E is very similar. So you can get it on your calculator by going e, and it always wants it to the power of something. So you can just write it to the power of 1, and you'll get this number. And as you can see here, it sort of goes on forever and ever, never repeats. So you can do stuff like calculate e squared, for example. So it's 7.38. Let's go round that up. And you'll notice that we always really want it in the context of power. So we sometimes call this the natural exponential. It's also called Euler's number. Fun fact, Euler did not discover it. It's just named after Euler for some reason. But that's why it's called E for exponential or Euler or whatever. We also have natural logs. So ln of a number, this is just log in base e of that number. That's what ln means. So log of e5 would be 5, because you'd be asking the question, e to the power of what gives you e to the 5? So, well, yeah, the answer is 5. ln of 10. So we saw that e to the 1 is 2.7 and e squared is 7.3. So I'd maybe like 2.3-ish, something like that. And we can work this out. So log of 10 would be, hey, 2.3. I'm going to go 2.30. If you just want to be able to do the maths, you can pretty much stop the video here. But if you're curious about what e actually is, the best answer is wait until next year. It's got something to do with calculus and like slopes of functions. But I've got a fairly good answer here as to where it originally came from, which is compound interest. All right, so we'll see how this works. So I put the $1 in the bank account at the start of the year. And then by the end of the year, I have $2 because I've basically just gained 100%. 100% of $1 is $1 more. Now, we're going to do the same sort of question here. We're just going to compound it twice here. So you're still going for 1 year in total. You've still got 100% interest per year, and you're still putting $1 in. The only difference is we're just doing the compound twice. So I'm going to start with $1 here. Overall, I would like 100% interest by the end. But that means that from the start to the 6-month mark, I'm going to get 50% interest because that's half a year. And then I'm going to get 50% interest again because that's half a year. So the way we get to the next step on our table is we want to take the $1 that we started with, and I want to times it by 1.5. So the 1 from that formula is for the 100% we're keeping of the $1. And then the extra 0.5 is the extra 50% we're gaining. So I should get 1.5 there. So $1.50. And then if I want to get the next step in my table, I just times by 1.5 again. So it's $2.25. So you will notice that everything sort of stayed the same. The only difference is I just compounded it twice. And I get more money after 1 year. Now compounded quarterly. So with this, your time in years is going to go 0, 0.25, 0.5, 0.75, and then 1 year. So it's compounding 4 times a year. I'm going to start with my dollar. And basically, this will be at the 3-month, this will be at the 6-month, 9-month, and full year. That's how this one works. If we want 100% interest by the end of the year, I need to go 25% each time. So this will be timesing by 1.25. And let's see how this works. So I got $1, and I'm going to be timesing it by 1.25. So I get $1.25. I want to times it by 1.25 again. So I get 1.5625. We'll use the full versions here. Times by 1.25 again, I get 1.953. And there may have been some more decimals, 125. And then we go to times it again. So 2.44 or $2.44. So you can see here that once again, quarterly is better. but not the same amount better. You can see that here I gained 25 cents. And then when I went down to here, this is an increase. It still is a pretty good increase, but it's 19 cents more than the last sort of jump we did. So there may be some sort of limit here. All right, now if we do compound it every week, we could do a big long table like this, but it would have 52 rows because there's 52 weeks, and we don't want to sit here doing that. So let's review how we did quarterly. We did 1 times 1.25, and then we had to do that 4 times. And that's essentially how we got the last entry in our table. You can write this as 1.25 to the power of 4, and we want to think about where this number came from. So this was the 100% plus the extra 25%. So this essentially is 1 plus, and the 25% came from the 100% over 4. I'm just doing everything in decimal version, but you get 1.25. So it's like 125% if you work it out as a percent, 1.25 if you work it out as a decimal. So let's see if we can do the same thing for weekly. So our weekly formula would have to be 1 times, and then the number here I want would be 1 plus 1 out of 52, because there's 52 weeks, to the power of 52, because I do it 52 times. Now we can see if we go onto the calculator what we're going to get for that. So 1 plus 1 over 52, all to the power of 52, should give us this number, 2.69. So this roughly equals 2.69. Now if it's compounded daily, this would be 1 times 1 plus 1 out of 365 days in a year. We'll assume that it's not a leap year, and we can figure out roughly how much money we get. So 1 lot of 1 plus 1 over 365 to the power of 365, 2.71. Okay, so we can see that the money is getting much, much better. So if we do it every year, we get $2. Twice a year, $2.25. 4 times a year, $2.44. If we do it 52 times a year, we get $2.69. And if we do it daily, so 365 times a year, we do it $2.71. You can probably notice that the growth here is slowing down quite a bit. That's the only thing. And I wonder what the limit is. If you're familiar with the number from the start of the video, the limit is E. So pretty much if you look at E to the power of 1, that is 2.718. And you can see that by doing interest daily, we've almost got E. We've got 2.714. So if you want, we can write E is, so it's basically, you can forget about the 1 times at the start, but it's 1 plus 1 over n to the power of n. And this really, limit as n goes to infinity, that means we make n really big. As big as we can make it, and that would be exactly the number E. And then it gives you this funky, weird number. So if I try 1 plus 1 over, let's go 1 with 4 zeros at the end, and then we'll raise it to 1 with 4 zeros at the end. You can see I'll get roughly what E is. And it comes from that compound interest stuff.